Good morning, viewers, and good morning, learners at home. Today we are going to take a look at another aspect on the metric system, and this is titled capacity. Capacity. What is capacity? Capacity is the amount of dry or liquid materials an object can hold. For instance, if I have a container, I hold this container, I can fill it with water, I can fill it with kerosene, I can fill it with any soft drink, or I can fill it with grains of rice. The amount of that material that will fill it up, that is the empty space that is within the container, for instance, can be referred to as the capacity of that container. Now, I want us to briefly take a look also at the definition of volume, even though we are not treating volume proper. But I want us to also take a brief look at that because volume is similar, it's simultaneous to capacity. And the volume can be defined as the quantity of material that an object can hold is referred to as as the volume of that particular container. If I pick a box and I fill the box with water, and when it is filled to the brim, I pour out the water into another container, maybe a calibrated cylinder. The amount of water in that particular calibrated cylinder pour from the box, that is probably a plastic box, into that calibrated cylinder is referred to as the volume of that container, which can be read through the calibrated cylinder. Now let's proceed further. Units. We have the basic unit of capacity is liter. Liter in British system is spelled this way, but in the American system it is spelled with E before the letter R. An abbreviation, letter L. Now let's go quickly to conversion. How do we convert? Because our major concern here is how to convert units of capacity from one to another without any stress. We have, for instance, here a whole number. We have here the first decimal number, and that gives us 1/10. This is 1. When it comes here, it becomes 1/100. When it gets to milligram, it becomes 1/1000. 1/1000. Now, when it gets here, it becomes 10. That's decaliter. When it gets here, it becomes 100. Hectoliter. And when it gets to this column, it becomes 1000. So this column is referred to as kiloliter, hectoliter, decaliter, not deciliter. Please take note. Decaliter. This is liter, this is deciliter. And that's why it's denoted with small letter for easy identification. This is centiliter and this is milliliter. So 1 liter under deciliter, we have 1/10. So one of this. So when we have 10/10 deciliter, it will become what? 1 liter. When we have 100/100 centiliter, it becomes 1 liter. When we have 1000/1000 milliliter, it becomes 1 liter. But when we have 10 decaliter, it means 10 liters will give us 1 of this. And 10 of this will give us 1 of this. This is hectoliter and this is kiloliter. So it is in this form that it functions as decimal. This can also be expressed as 0.1, this can be expressed as 0.01, and this can be expressed as 0.001 in the decimal form. So that is the rule under the conversion. Now I would like to take you to the next level, which has to do with the calculation. So let's quickly take a look at the calculation. Now we have 2 examples, but we're going to treat one in this class and treat the second one in the next class. Convert the following to the indicated units. we have 15.6 liters to be converted to milliliter. Using the table, which is, I said, it is the 21st century methodology. It's easier and simpler. You don't need to multiply anything, no racking of brain in solving this question. All you need to do, enter the figure in the table. But as you do say, make sure that the units are in this order. If you mix them up, it won't give you the correct answer. It must be from kiloliter to hectoliter. You can't replace hectoliter for decaliter. It can't work. You can't place centiliter under the column of deciliter. It won't work. So you must learn this table and make sure it is arranged in this form. Then you are free to solve any question, whether whole number, whether decimal number, whether mixed fraction, whatsoever you are given, you can use it to solve it. So let's solve this question quickly using the table first, which is the simplest way. What do? Locate the liter. This is liter, and this is milliliter. Here we have milliliter, and here we have liter. So this is liter here. Now, this figure is a decimal number because it contains a decimal point, which means this 6 can't enter this liter column. No. The C's should not. Rather, it is this that is the whole. So the first figure to the right-hand side of the decimal point is the whole number. So that's where the unit given starts from. So you fix this 5 in the liter column. So this is 5. Is there any figure in front of 5? Yes, as you can see, 1. Then at the back of the 5, is there any figure? Yes. It goes into the next column. After the 6, is there any other figure? No. Then you go to milliliter and fill it up with nothing, which is 0. With this, you have ended your work. That's the end of your conversion. What do? I said go back to the table, copy it as your answer. That's all. This gives us 15,600 milliliter. That's the answer to the question. You are through. You are finished. You have nothing to wrap your brain all about. But when you want to go through the manual way, which is the real calculation, then let's quickly take a look at that. It gives you 15.6 to be multiplied by. Now we are changing from liter. We are moving to milliliter. So you locate the meter on the table. You put your finger on it. That is 1. Then we are going to milliliter. This is milliliter. So count how many zeros before you get to liters. 1, 2, 3. So that's 1,000. So multiply it by 1,000. Then it becomes a milliliter. And this gives you what? You shift the decimal point by the number of zeros. So 15.6. Shift the decimal point by 3 digits. 1, 2, 3. 0, 0. And this gives you 15,600 milliliter. But in case you still don't have the good knowledge of this table, you still find it a bit difficult, depending on the question. It could be from hectoliter to decaliter. And it's not all that common among the questions that are in most of the textbooks. But with this table, there's no question you can solve under capacity using this. So with this, we've come to the end of the first example. See you in the next class for the next example.